Welcome in everyone to Tofu Tech Talk. This is a little podcast segment on my Twitch stream where I invite STEM researchers here on Twitch to talk about the research, to talk about their science, and just to nerd out completely. And we have a special guest to this week. Rocket Sage, thank you so much for coming on Tofu Tech Talk. Please introduce yourself as much or as little as you'd like.
Thank you so much for having me. My name is Rocket Sage. You can call me Sage, Rocket. Either you just call me the whole name. It doesn't really matter. I'm a geologist by profession. Specifically, my niche in geology is geochemistry, sedimentology, and then generally just earth science. I've become very well rounded, I think, because of the content creation I've done and teaching many courses over the last 8 years at university has allowed me to curate more information, which has been fantastic. So I haven't actually done much research in the last 8 years, but I do have publications to talk about if you want. It is a topic called diagenesis, which is a little niche and probably a little boring. I won't lie. And there are many other things that we can talk about that are related to my thesis or things that I've worked on. But you can ask me anything about the earth sciences. If I don't have an answer, I will simply say I don't know.
No, I like the fact that we are comfortable enough to say, I don't know. That's very, very
Mhm.
important.
Thank you.
But yeah, you sent me like you sent me like so many
Well,
things that you know and that you're interested in your research. So you have a really, really broad background. And I'm not a geologist. I don't know a whole lot. So what I'll probably do is I'll ask very basic topics
sure,
that you brought up and we'll
sure.
see where it goes from there. And obviously, if
Sounds
anyone in the
great.
chat wants to ask live questions based on anything that Rocket Sage has said, make sure to log and use the channel points. You can get a good few channel points um, uh, to log the question. That way I can keep track of them if they're lost in the chaos that happens. So
That's absolutely great.
one of the things you said that you're really interested in is water issues globally. Now,
Mhm.
what does that mean, water issues globally? Obviously, I know what the words mean, but put
Yes.
them together.
So for geology, a lot of people I think don't realize we study in depth the hydrocycle. We dive deep into all things water on Earth. The most of obviously the most abundant source of water is the ocean, very saline,
Mm-hmm.
not drinkable unless we would do desalination, which is very expensive when it comes to energy. So it has been done. There is some desal, but primarily right now, our major source of fresh water is groundwater, followed by lake streams, floods, rivers, all that. So stream water, fresh water that's on the surface is actually by far less common than groundwater is. And so when it comes to especially groundwater is where I get extremely passionate. It's not just groundwater, but it's that we rely so heavily on groundwater for agriculture in so many different countries that uh we like it's hard to just like I teach a course. Let me back up just a bit. I teach a course called Water in the West, and basically it focuses on the water issues in the Western US, about the Southwestern US. But it does go into a little bit of the political background and some of the
Mm.
shisty nature of the government back then. And while
Geopolitics,
still,
yeah.
yeah,
Mm.
it does get into geopolitics a little bit. So depending on whatever you're comfortable with, we can stop it at any time.
No
I don't
worries, no
like to make
worries.
anyone, yeah. So that's where it started for me, and I realized, like, this is these depletion issues is one of the things. So you asked what are basically the issues. The main issues are depletion, rapid depletion, such that it is not sustainable because we are using a resource, a freshwater resource that does not recycle on human time, it recycles in geologic time. So I'd say maybe if
Oh.
you completely depleted an aquifer, and I mean, you wouldn't, because the bottom of the that aquifer is real brackish and saline. So if you depleted, let's say, all the fresh water, you would actually be permanently destroying part of the storage, and you would the land would sink a bit. So if any infrastructure built there, they would be affected. But the other issue that I also go into are contamination issues. So water contamination, whether it's groundwater or freshwater, they are cyclical. They all kind of tie in together. So if you fresh water, let's say you have an acid mine drainage from a mine,
Hmm.
and that gets into a stream, well, that stream infiltrates directly into the ground and feeds whatever that groundwater. So it's very all tied together. So it's it's a lot depending on the geology of the region. And no, I don't know the hydrogeology of every place on earth. I know where there are a lot of issues
Mm,
and places that I'd personally like to go to help,
mm,
because especially unfortunately, the poorer the nation, the less general help that they receive, the more issues they often have, because they do get oftentimes taken advantage of for
yes,
mining and oil and gas.
I see.
I'm sorry that was a much longer
No,
winded
no.
answer than I
Just to kind
expected
of
to give.
go back on the earlier, to say that this is something that I don't talk about in my stream, and I don't think I've ever even come across it. That the statement initially, is it implying that in the long term, because of mankind and the way we have their systems in place, is it that we're going to be running out of fresh water? Is
Yes.
that, and on what scale is this, time wise?
Mm, I personally, so for California, the situation is really messed up politically. And basically, there's a handful of billionaires that are taking the water, making crops that are money makers, growing crops that aren't necessarily standard for any one country, but they're making crops that make them the most money. And
Okay.
then they export most of that out of the US. So they're just taking the water, making stuff, selling it elsewhere. And that water, our groundwater, is actually depleting very rapidly. I personally want to get out of the state in 10 years because of the water issues,
Jesus.
especially.
10
Um,
years.
I don't think we're going to be out. I think that there are people in office that are thinking about these things. I don't know how much information or education they have, or if people are just kind of blindly looking away. I don't really exactly know what's happening so much on the political end, and why. I there are parts I know, parts that are hidden to everyone, I think.
Oh, wow. I
But
haven't even come across this in news articles
it's
myself. Like I
oh yeah.
do keep an eye on, as my field of renewable energy and electric grid, I still keep an eye on that kind of aspect of the world. And that isn't on my radar. I don't really know about this.
Yeah.
This is
Yeah.
very
No, it's
surprising.
it's a very different issue, and I don't think people really think about the hydrocycle because, well, it's a geologic thing, and geology really isn't a very well-studied science globally. It is a very
It's
well-studied
new.
science.
It's new.
It's newer. For example, plate tectonics didn't become a theory until about 1958, so 1960. About
Mm.
60 years ago, maybe almost 70. And that to me blows my mind. It's like, how recent are we? And literally what they thought before that was that the earth had just cooled in place. That was the main theory, that all the surface of the earth had just cooled like that.
And we're
And people were like,
stationary.
wait a sec. Yeah. So plate tectonics is really new. The whole field of geology is still relatively new. And it does involve physics and chemistry and math and programming and biology. And depending on the niche you want to get into, I'm kind of more on the chemistry side. And it's amazing the things you start to learn about that you never intended to learn about
Mm.
through the geosciences. So yeah, the hydrocycle is one of the big things we study. We have an entire like week lecture on surficial water, and then we have an entire week lecture on groundwater, because
Two
groundwater
separate.
is so important to us
Mm.
as a race. It's been used for a long time, and I mean,
It's
dowsing
used in
rods
everything.
have
It's
been
our
used for,
drinking
yeah.
water. It's our farming. It's
Yep.
I'm guessing it's also used in industry in
Oh
mass
yeah.
scales as well.
Oh,
It,
absolutely.
mm,
And I mean, our lawns, our water heaters, our everything. The more complex a society gets, the more needs essentially we have
mm.
of that source. But it's easy. It's actually relatively easy for people to cut down on themselves. It's the problem in most cases. I can't say for every single water issue in every country or state or territory is the same, but in most issues, it's not so much the individual consumer that's causing a major issue. Because, for example, when Governor Jerry Brown was like, hey, we need to cut back 25%, everyone needs to cut back 25% on water in California. And that was not meant for anybody in agriculture. So they excluded agriculture from that statistic, which is
Mhm.
where by far most of the water goes. About 80% of the water in the state goes to agriculture. And that's a normal statistic. It's between 70 and 80, depending on the crops, depending on the location in the world.
Time.
So
Mhm.
I don't want people to think like, oh my gosh, 78. No, that's actually normal. Our food needs a lot of water. It is the case, however, that some places are mismanaging what is being grown because, well, politics get involved and people want to make money. And then there's situations where entire systems get contaminated through harmful mining practices, bad mining practices, bad oil and gas practices. And depending on the country, the standards aren't the same everywhere. So you don't
Mm.
necessarily have the environmental scientists, which are also a geologic niche, um, protecting locations. We're like, hey, you can't do that. Not every country has a system like that in place to fine you for contaminating something important. Um, and I mean, we didn't in the US for a long time either. In fact, we didn't have groundwater regulation in the state of California until 2014, and that's still not going to be implemented until 2045. So they can still take all that groundwater for quite a while. And
2045. Wow.
right. And when I said like when you asked what timeline do we think water
Yes.
resources are going to be gone, I don't know that there is a specific true answer to that, because the best we can do is
Mm.
estimate, of course, the volume. And there are probably hydrogeologists out there better equipped to answer that question
Mm.
than I would be. So my educated guess, as somebody who's actually, I've taught hydrogeology once before, it was a long time ago, but as somebody who's into this part of geology a lot,
Mm.
is that I don't think California is going to be just out of water in 10 years. That's my personal deadline for trying to get out of the state, because I don't want to start dealing with the issues when they start to roll around. And we've seen towns dry up during summers since 2012, about,
Okay.
if not earlier. So that's
Okay.
just California. And then there's also the desertification happening in Africa, where their aquifers in the northern half of the country are being used
Yeah.
dramatically. And just like California, they are drilling more and more wells to procure more agriculture. And I don't know the political situation in that case, but it is something I could happily find at some
Yeah.
point. We talk about water issues a lot.
No, that's perfect. And there was just one question. I usually try to keep the questions till last, but Jimmy was just
Yeah.
on topic with his question.
Yeah.
So
Perfect.
before we jump or change topic, why would depleting an aquifer render it inoperable as a future water source? I.e., should it replenish over time?
It does replenish over time,
Hmm.
yes. And droughts and floods are completely natural. So don't think that this is all everything that's happening is all humans all the time. There's a balance.
Hmm.
And it's just, I believe that we're out of balance right now with our ecosystem. There are a lot of people now, the number of people and the amount of water discussion I don't want to get into personally.
Okay. No
Um,
worries.
that I think I do. The only thing I'll say about that is I really do think if we manage our resources right, that we would be fine. Um, I think we would be a lot closer to fine. Maybe not perfect, but much better. So I hope to see that come to fruition. But it's not that it won't replenish. It's that about 25 to 30% of that storage space that we call porosity. So aquifers don't exist like big pools of water underground, with the exception of like one specific rock type that is only in very niche parts of the world. And you can ask about that later if you'd like. But so 90% of the best aquifers are honestly unconsolidated gravels and sands. So that's actually the size. Like, you imagine beach sand. That is really one of the best, if it's not consolidated into a rock yet, if it's just like beach sand that's been buried,
Hmm.
that's one of the best storages for aquifers for water, oil, and gas,
Okay.
because there's a lot of space between all those little sand grains, and those spaces are connected. So what we call that in the geosciences, they have porosity, so space,
Hmm.
and permeability, because they're
Mm.
interconnected. So porosity and permeability are the big two things an aquifer needs to, well, replenish itself essentially naturally through the hydrologic cycle. So as we get rainfall, we get streams. The rainfall collects, turns into sheet wash, collects into streams and rivers, and some of that does infiltrate into the ground depending on the rock and soil beneath. And some places are harder for infiltration
Mm,
to occur. Some places are easier. Um, and it kind of just depends on a lot of little factors like the size of the pore space, the friction between the water and the rock, and the wiggliness, the literal straightness of the pore. If it's like if you're driving on a road, you go straight, you can go much faster than if it's a windy road near a
yeah, yeah.
mountain, right? So um, water highly depends on a lot of these other factors, but generally speaking, my estimation is about 20,000 years to completely refill an aquifer to before maybe we touched it. The thing is, we could perfectly, I think, use these resources with a balance. It's just we are in certain areas out of balance. A lot of people live in dry, hot areas, and
Mm,
agriculture happens to be good there. So we're using these resources to grow in areas that generally don't have a lot of rainfall and precipitation. So those
mm.
resources do get used up faster. I hope I'm not deviating too far away from the
No,
question.
no,
You can
no,
always
no,
pull me
no.
back if I am.
We will never stop a ranter. If there's anything on my community and my Twitch, we will never stop as a ranter because we have emotes literally dedicated for ranting. This is
Yes.
a thing. One time,
I think my community is gonna love you because of
perfect.
that.
I think we were studying how airplanes fly, and then we were learning about how
Ooh,
bees reproduce. I don't know how
don't
that conversation changed in 15 minutes, but it did. So
airplanes just flap their wings?
I think someone said bees can't fly by physics, and I went into a rabbit hole.
Wait, what?
Someone said that before. By the laws of physics, bees shouldn't be able to fly.
Oh, their little bodies are so
Yeah,
fat.
something like about their bodies are too fat, and
They're
yeah,
so
we had
cute.
to. Sorry, we got to. This is what I mean. We get distracted. There
No,
we go.
I'm the same way.
So I will conclude because I don't usually take questions right in the beginning, but just because it's so perfectly on topic. So the land
Mhm.
sinking due to the aquifer depletion could theoretically rise up again over time as the aquifer refills.
No,
No.
no. So certain things like clay, if you're in a dry area and there's like a basin, a low point that just dirt or dust, right? That's mostly clay, really fine particles.
Mm-hmm.
And so that can expand when it's wet. Clays expand when they're wet,
Yeah.
but clays also don't make good aquifers, don't make for good storage because they compact so well that any kind of permeability or the ability for water to flow through that type of material is almost impossible. It's very non-permeable. Those spaces are interconnected. So that is one example where you can have expansion of something that is getting wet. But unfortunately, most aquifers aren't made out of clay. In fact, most clays block aquifers. So you can
Okay.
have confined aquifers through clay layers. You can have actually aquifers existing underneath these layers that are made out of this impermeable clay, and then you can have another aquifer on top of that. Then they're completely different. Maybe the top one gets contaminated, the bottom one won't because of their separation. So that's another thing that can happen. So it does depend on the depth. It depends on the type of material. If it's consolidated rock, if it's literal rock, then it won't collapse as easily as unconsolidated material would. So if it's more superficial, you're going to have more unconsolidated material. So the more chance of collapse is going to be greater. When there is a harder rock, you would have less, I guess, consolidation. And what we call, by the way, the sinking of that earth
Mm-hmm.
when we overpump anything from the ground is subsidence, however you want to say it. I say it both ways just in case.
Not to offend
And
anyone.
yeah, and I'm like, I don't care how you say it. People will understand. Um, and these things, the grains within the aquifer mechanically rearrange
Hmm.
as the water pressure, that hydrostatic pressure isn't there anymore
Yes.
because those grains aren't just touching each other and holding themselves in place. That water is also offering a lot of pressure to relieve essentially those little grains from having to rely on each other so much to keep
Mm.
upright. So once that water's gone, they all kind of just crumble and fall and fit where they can. And if it's a hard rock, it will it can fracture. It can dissolve. I mean, there's a lot of things chemically that are happening, and that's where diagenesis comes into play, which we don't have to get into. But
No worries.
a lot of chemistry happens as you go with depth, because with depth, increase of temperature and pressure happens. The geothermal gradient increases. So that will not, it won't let the rock won't like expand again, even with water filling in those spaces.
Mm.
It's once it collapses, it is permanently done. So you're not going to have a destruction of 100% of an aquifer. It's more like 25 to 30% of it that will be destroyed if you completely depleted it.
Okay.
But there's an image. Let me show you a crazy image.
Yeah, sure. Do you want to send it to me, or do you want to share your screen?
I can just send it to you if that's okay.
Okay, that's perfect.
You can share however you
I can,
wish.
yeah.
Subsidence, SJV. You know the image I'm talking about, Volcano Doc. SJV, subsidence, water. I'm pretty sure that should bring it up. And I have it saved, but oh, that's an old one. Wait, what? For some reason my face popped up. Okay. That's really weird. I don't know. Where's it at?
No panic, no panic.
I think it was in 1922 that it started.
Volcano says with the 1973 sign.
Yes, I thought it was earlier than that. There's the recent one's the only one coming up, like the real recent. Oh, well, here's one, but this one isn't. I'm usually so good at finding this image. It's because I'm on the spot. You know
it's okay. It's okay. It's okay. If it's something that comes back, maybe we can go back around it.
Oh,
you found it?
I did.
Nice.
It's part A of this image. Oops. Copy image.
Oh, Tofu DM'd me. Volcano DM'd me the image.
You're amazing. I knew you'd find it fast. I knew you would.
So I have some. I will screen share this, I guess. Let me just I will do a display.
I can always pull it up if it's easier.
Oh, there we go. I'm doing a weird display capture here. Nobody look at what I'm showing the world. There we go.
I can do it.
There we go. So it's an image. Is this the image?
Yes.
Oh wow.
The height of the ground in 1925 was where that sign was, yeah, and the height of it in 1977. And there's another image today that is further. It's further down.
Oh wow.
It's since about 1960 we realized, oh no, we're using so much water, and they kind of made some efforts to decrease the use. Mm-hmm. So around that time, land subsidence did decrease in rate at which it was sinking, but it's still sinking today. So that picture is more impressive in terms of showcasing how bad it is relative to the new one. But it's a good thing that the new one isn't sinking at the rate we used to be sinking at.
That is so fast, Jesus.
I know.
That's a loss.
And I mean, when you think about it too, like it's a lot for us as humans, as I imagine us as little ants, as a geologist, sometimes like we're just little ants scurrying around. And I mean, our aquifers, they're voluminous, they're big, they're not just a single plane sinking. So there is, like, I don't want people to freak out either. At the same time, I want people to understand.
It's the apocalypse. It's the end of the world.
Because I really do believe that there are solutions to maintaining and managing our water resources in much better ways, just like we're working on solutions for climate.
Absolutely. No, thank you so much for informing. Like I said, this is something that I'm just not even like properly aware of. So it was really insightful to explain everything and to go into detail. We'll go over the logs of other questions future. Again, I just jumped in on those questions because it was just perfectly in theme that Jimmy jumped in there. But you've so many fields, so I'm just gonna cherry pick because when I was speaking to you briefly, you talked about carbon capture and storage. And I know what those words mean. I know what a capture is. I know what a carbon is. I know what storage is. But I don't know what those mean in combination when you said it. I was very
That's fair.
embarrassed to say that I didn't know what that
No,
meant.
no, it's only one of the many solutions being worked on to mitigate greenhouse gas effects right now.
Okay.
So it's not something I would expect people to just know about
Okay.
unless you did work in that particular niche of climate.
Okay. So it's
Because even in
working.
climate, because you've done a lot of climate work yourself, and then we do a lot of climate in geology too. So I think honestly, climate has become more of a every science field.
Climate touches everyone,
And
yeah.
it does. So it's very, very vast and it's easy to miss. We used to call it carbon capture and sequestration. I don't know. They changed it to carbon capture and storage, probably for folks to have an easier time understanding what it means. So literally what we do, just on the basic terms, we take CO2 as a supercritical fluid, which means it's both in the fluid and gaseous state at the same time.
Wow.
Yes. So it's a supercritical fluid, which because it's kept in a state that's both gas and liquid, it has to be under a lot more pressure because we experience, at 1 atmosphere of pressure on the ground surface, right? We experience so much CO2, right? And we don't
Mm,
see it. It's in the gaseous form because we're not under more pressure. Now, the more and more pressure increases, those phases do change, I think. And
yeah.
if, yeah, I'm sure
No, I could jump in with my
Tofu can,
thermodynamics
yeah,
graph, my pressure and
right.
temperature
You
graph
know
here.
much more about this stuff than I do.
No, it's cool. And
But
and so it's in a canister. It's in a.
so no, so all these aquifers, it's kind of a great segue that you picked this topic because all the aquifers I'm talking about, um, well, oil and gas is stored in the same way that water is, in pore spaces that are interconnected,
Mm-hmm.
such that it can actually flow. And typically, the oil and gas likes to rise,
Yeah.
so it usually needs a kind of cap rock. What I mean by that is like clay, like we talked about. That's something not easy to flow through or almost impossible to flow through. And that's why we get those oil and gas storages, is because they rise and they get trapped in a variety of geologic ways.
Okay.
And so that stuff gets trapped, and oil and gas companies come in and they drill a big hole like a straw, and they essentially pump that stuff out. The thing is they can't quite pump out. There's about 25% oil, especially oil over gas, that remains in these aquifers because it coats every single grain or rock face that's in that storage system. But there's also a lot of space that's empty now.
Mm-hmm.
So they turn CO2 from, let's say, an oil processing plant, a
Okay.
refinery. And instead of letting that CO2 just go into the atmosphere, they would instead turn it into a supercritical fluid, and then they would pump it into those old oil and gas reservoirs. And this is what we did for my thesis. So there was a place called McKittrick for mine, and we looked at about a depth of 10,000 feet. And there's all these requisites, like it has to be, if there's any water in there, well, there is groundwater in there, but it has to be brackish, saline. It can't be drinkable water. It has to be below 3,000 feet deep. Yeah, I know it's not metric. I don't like it either. And
You said 10,000 feet like 2 seconds ago, and I had to do some
oh,
maths in my head. I was
that's
like, what does
well,
that mean?
so it's about 3,300
Yeah,
meters or so.
yeah.
And that was about the depth of my aquifer, but it has to at least be about 1,000 meters deep,
Okay.
and or 3,000 feet deep.
Wow.
And the parts per million of the salinity of water has to be over 12,000 parts per million. And it has to be able to withstand any kind of geologic conditions for at least 1,000 years. In my opinion, 1,000 is nothing. I'm like, what? We
In the
could still be here.
yeah, in the
That's
geology
not
scale.
good.
Yeah.
So I think on geology time scales a lot, not on human ones. So I mean, that's 10 generations. That's actually a pretty decent amount of time when I think about it from the human standpoint.
Mm.
So they take these old oil and gas reservoirs that have been partially emptied, and they can't pump any more out,
Hmm.
and they pump in a supercritical fluid directly from the refinery into the reservoir, and they have to again assure that it stays there, that it's going to, because it will rise into the reservoir and fill it. And stays in those conditions because it's under enough pressure due to the depth that it is kept as a supercritical fluid. So it just stays in that supercritical fluid state. And that's the idea, is just to, instead of allowing the CO2 to escape into the atmosphere, instead we're going to pump it in the ground in old reservoirs. And oil companies, it is actually being done. Oil companies at first didn't like it.
Yeah.
Which is weird because oh, go ahead.
I know. Is this a new technology? How, like, is this old? Because
it started.
This is wild as well to me. Like, how it even came up, like, how people came up with this.
I actually had an argument about this. There was somebody online who posted misinformation about this, and they were like, it started in the 50s or something. Like, no, it did not. I think the earliest research that was ever even considered for CCS, I want to say, was 1973.
Okay.
But this was, again, 3 years ago that I looked up the state, and that was even just like a seedling of a thought.
Yeah.
Right?
Yeah.
That wasn't the
beginning.
Things happening. And I don't think started in the US, we didn't start doing CCS until after 2000. And it was, I want to say, I knew it was, the first I knew of it happening was about in 2010. And then I finished my thesis in 2015. 2016, 2015. It was I think 2016 February. I had to wait for my advisor to come back from ice climbing for 4 months.
Of course.
So they let me teach. But he's lovely. I love him so much. And
I think that's just perfect. By the way, ice climbing from a geologist, that's just perfect.
Well, he was kind of 1 foot out the door, but he had 3 students left, 2 of which were kind of not trying very hard, and I was the one who was like living on campus. So I basically didn't really need him that much. He would tell me what to do and I would do the things, but then I would get it done too quickly and he'd be gone ice climbing, and I didn't mind. Like, I got a great opportunity because of that. They knew my thesis was done. They knew I was ready to defend, and they're like, do you want to start teaching here? And I'm like, yeah. I didn't have a
job. Yeah, that'd be great.
So I had no teaching experience. So it's like, yeah, I'll take that experience.
Nice.
So it was actually a really good way that it all panned out. But that's the timeline roughly of when carbon capture really started to take off. I know it was like a seedling of an idea in about 1973. And there is one book I can reference that's called, I think it's actually called Diagenesis.
Oh, Diagenesis.
And it is falling apart. That book is falling apart. That's my thesis. It's all the chemistry that happens at due to burial and the depth of things and what rock does. But
okay.
So the carbon capture, sequestration, or storage, as it's now called, is actually being used. And while I was doing my thesis and finishing it in 2016, I knew it was being done in Texas. I don't think it had started being done in California yet at that point. And they did find my location was too small volumetrically, so it was just not enough space. And there were other, which this is the fun part, I think. So I was doing like the baseline analysis of this reservoir to determine this just information, what is there, what it's like, what are the changes currently happening. And I got to do a lot of scanning electron microscopy doing this, but one of the really neat things I feel I got so lucky with is because I ran the SEM lab over 4 years, all these other projects doing the same thing I was doing, but at different locations, the next step would be to take the rock from my reservoir and put it in a glove box with supercritical CO2 over a period of so many months to see what the reactions are, what happens to the rock. And then I would look at it in the SEM. I was the one who got to first look at these things under the SEM for our department, me and my advisor. And it was so cool to see what minerals would dissolve, what minerals wouldn't. Like, we weren't sure.
I'm just surprised how like minute you were studying, because under the SEM, like it's a scanning electron microscope, very, very tiny, very zoomed in image. You were really studying at a like almost surface level what is happening to every rock, every layer with this at every stage. That is like, I would have assumed you guys would have experimented quite like out there at a larger
Mhm.
scale. But it's so interesting to see that you were also
Right.
looking at it at a very tiny scale too. What was
Right.
happening?
It was I got to well, so when they drill oil for oil and gas, they have to pull all this rock up first and they collect it all perfectly. They keep it in order. They mark it for depth and you can then go into these reservoirs. Well, oil companies are kind of stingy with sharing that rock if there's an active reservoir because they're like,
Oh,
oh, if they get that rock, then they'll know all our secrets and steal our monies. And I was like, wait, I just want to do some geology. So I was lucky to find enough old oil reservoirs in the area that I could study. And then you have to take them to the rock saw, which is a wet saw, cut them into samples. I actually did polish some of my own samples, coated them in carbon because you coat them in platinum, gold, or carbon, I believe, for the SEM. We used carbon. Put those in the thing, had other thin sections made. So I've gone from having the physical rock in my hand to looking at these things on a micron scale. So just to imagine for a moment, the electron beam an SEM produces has the diameter of 10 microns. It's very, very small. And sometimes when you get the sample out, you can see all these little dots, like tiny, 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 tiny dots of where the electron beam like zapped the sample. And you're like, I zapped you with electrons. It's just so cool.
For me, it's more cool seeing it live, you know, when you have the video
Yeah. I
camera
wish I
and
could
just
see
and
the
see.
beam.
Oh, because the way you described it, I didn't realize it was photography. I only worked with video SEM, so I saw over time you
Well,
couldn't expose it too long, otherwise the video would, you know.
yes. There are different ways to use the SEM. The way I use it is in the backscatter electron
Mm.
imaging. So it was two-dimensional grays. And you basically, based on the tone of gray, you're like, I think that's albite. I think that's quartz. I think that's feldspar. I think it's pyrite. I think it's biotite, muscite, whatever. And you zap it and you get a chemical analysis of what it is exactly. So the elements of, so for example, SiO2 is quartz. So you'd get a peak of silicon and a bigger peak of oxygen.
Yeah.
And you'd be like, okay, that's quartz. So that's what I got to do. And then I would have to describe any kind of deformation and things like that. But those, I would take the baseline data and then I didn't ever get to put the samples into the glove box, but I got to study the samples afterward. So I'd get to see which
Oh.
minerals firsthand were actually dissolving in the face of supercritical CO2, which was, I think, so neat because I'd see the samples before and then I'd see them because some of the students were supposed to do the SEM work themselves. They're like, "You're really good at this. You're really fast. Will you do the details? I'll put you on my paper." I'm like, "Yeah, I want another publication."
Nice.
So I did. I did a lot of zaps.
Damn, that's what I should have done. I should have run the SEM lab.
Oh my god!
Actually, the SEM broke.
We
Never
got
mind.
a new one, and I'm when they come back in the fall, I'm gonna
play with it.
learn the new one, play with it, and I'm actually gonna look into getting trained to fix SEMs, like because I am just so obsessed with the SEM.
It is very expensive to repair one. Just to call in a technician costs 10,000 euro. I would know.
That's why I want that job. I want that job. I don't make very much. I want that job.
Just to call them in. Okay, I'm not going to go on a rant. That's a different rant. We'll say
it
that.
is a great rant though. But there's a because it is insane. But there's not that many people with that skill set. I want that skill set.
Yeah.
So one other way in which you can actually store carbon isn't just the way that we did it. I'm only going to give this example because it's a fairly easy one to understand. And I think it's so cool that Iceland is doing this.
Oh, Iceland is always an awesome topic for geology.
God, I love it. So Iceland more recently decided, hey, we're going to just carbonate water and pump it into our rock, which was brilliant because the rock there is all volcanic. It's all basically the same kind of rock and it's all calcium rich, which if you have CO2 and you have calcium and they bond, you get calcite. Or, I mean, you could theoretically get aragonite. This is the same oh man, my lights are washing this out. That's okay.
It looks cool still though.
It is. This is the same chemical formula. It's calcium carbonate. So CaCO3 would be the chemical formula. And this is different than calcite because the structure is different. Another topic for another time. But basically a mineral with the same chemical composition, very similar to this, naturally just forms, or what we would call precipitate,
Ooh.
into the rock and becomes very stable. So no longer is that carbonation going to escape. And it may not be as simple as just carbonating water. There's probably more they do. I would need to do more research because mine is in specifically with supercritical fluids, right? So
Yeah.
I don't know if it's just as simple as carbonating their water, but basically it is a simpler process, and it's a more viable process long term, in my opinion, because the mineral calcite or aragonite, super stable. It's a naturally occurring mineral that makes the rock limestone that is so common. It's so
Mm.
common. So it's a human unnatural way to naturally kind of put it back into the geologic storage, so to speak.
No, that's really, really cool. And Iceland does come up. We had Volcano Doc on TofuTechTalk about a month ago or so. It must have been longer than a month ago.
She's
But
awesome.
it's also like, I don't know. Iceland always comes up for some really cool geoenergy, geology based anything. Oh, it's just such a great country.
It is. It's so cool.
And then I'll guess, so we covered waters, we covered the CCS, and I suppose we kind of covered minerals. I suppose I will ask one last question, and then I will go through all the questions that have been logged, and
Sure.
it could take a while, honestly. It sounds like
That's
we're
okay.
approaching the end. We're not. But I'd like to give
whatever time you need, it's fine.
We'd like to give credit to something that you created, or we're one of the creators here on Twitch, that you've been streaming here for a very long time. You have been a science communicator here for a very long time, and you are one of the members of the Knowledge Fellowship, as in management members. If you'd like to give like an opportunity, a talk here to show what science communication was like on Twitch for the longest years, and how TKF formed. I say TNF because the K.
Oh my gosh,
my brain doesn't work.
When we first made that acronym, we were like TFK, TK. Wait, what?
It doesn't work in my head.
No, it is a very strange acronym. And looking back today, I don't know if I would have wanted the same name. I like it, but I wish it would more encompass like, hey, this is free live streaming rather than the Knowledge Fellowship, I guess, or free education. But I think we get that across with our mission statement pretty well. So I started Twitch 9 years ago. I never ever thought, I was in my master's at the time. I never thought I'd be doing geologic stuff. I never thought I'd be even a live streamer. I never thought I'd do anything with social media. I just wasn't a big social media person. Didn't really care. I just loved being outdoors doing research, and loved the lab and loved doing outdoors. That's the cool thing with geology, is you can do research outdoors in the field. I've mapped for the USGS. Great work. You can do lab work if you prefer. You can do both. So if you're not an outdoorsy person, it's still like you can still do so much in the geosciences. It's great. So in I don't remember, 9 years ago, I was like, my friends saw me playing a horror game called Amnesia: The Dark Descent. I'm like, and they would just be
Amnesia.
sitting there laughing for hours. And I love horror games. I grew up playing video games on computer. I played all the Diablos, all the Warcrafts before WoW came out, all the Starcrafts, even the old Wolfenstein. Like, God, what was there? So many games, so many little games I can't even remember. Duke Nukem, all those old school games.
Of course.
And so I come to Twitch thinking, okay, well, because my friends would laugh at me, thought it was funny I was playing horror games, that I couldn't play these scary games by myself. I was like, I need you guys to be here. And they're like, why don't you just live stream it? I'm like, no, what? No. Like, can you be here? I'm anxious. I don't like getting in front of people. And they're like, no, you need to go on Twitch and live stream this. I'm like, I like watching it, but I don't need an account. It's fine. And they're like, no. And they finally just like pushed me into doing it. And I had this shitty little gaming laptop that I saved all this money up for because I loved gaming and I wanted to be able to play Hearthstone while I was running the SEM and other games too, because the SEM, like, you click 50 zaps or points of interest and it takes like 30, 45 minutes to run. So, it's kind of like watching paint dry. So I saved up for a gaming laptop, and and I was happily playing, and it turned into this Frankenstein thing with monitors plugged in, the speaker, like all this stuff. It's all this like cheap stuff at the time. I would never recommend, if you're going to start streaming, to start with buying all this stuff. Like, this was a curation of things over 9 years. This is not like all of a sudden I have this stuff, so I'm going to go live. Like, don't do that. You don't know if you're going to
over
like
time.
it. Right, right. Like, make sure you like to do the thing, because I had no idea. I wasn't. And suddenly I start streaming all these horror games. I build up a little foundational
Community.
seedling, and everyone was lovely. And Twitch was it's like baby Twitch back then. Things were wild. Things were wild. And they were kind of strict on the content you could do back then. It was starting to take a turn right when I started, such that you could start doing other kinds of content on the platform, not just gaming. I was under the assumption you could only do gaming. I had a huge geologic map of California on my wall in the back, like giant, like 5 feet by 4 feet. It was huge. And it's technology hoarding. Yes. Sorry, I just thought that was funny. People would ask me about it. So I'd ramble about geology all the time. And I found, like, I could just talk about this, because I'd have to pause the game. I'm really bad at talking and playing a video game at the same time. So, which is ironic that I did that, but I did. And then I was like, I saw a streamer one day doing education on the front page. I was like, wait, what?
On the front page?
Yes, on the front page. I was like, we could do this? Like, my eyeballs literally rolled out of my head down the hallway. I'm like, what is happening? And I was so excited. It was astronomy. I was so excited. I don't remember her name anymore. I don't know if she even does astronomy anymore, but there was the foundation of education on Twitch, by the way, is not the educational community TKF that I co-founded. It's actually a group called Brain Bites. So I would like to give credit where credit is due. Star Strider, Horizon Sign, Demon Machine. There's a guy named Mike Sai, Skylius, Kit Boga, and I want to say 2 others. And they were in this group, and it was around for a couple years. And we didn't know really what the deal was of whether or not we could like join or not. They did add me, Dr. WD40, and Moo Hoodles, because the 3 of us were pretty early on too. We like basically right there with Brain Bites. We just didn't know about Brain Bites. But I'm sure some of the Brain Bites folks actually did start earlier than us. I know they did. And we didn't know what was going on. So we're like, well, why don't we just make a list of people that do educational content on Twitch? So literally, the Knowledge Fellowship started with a Google Doc that Dr. WD40 and myself made.
Of finding educational streamers on Twitch.
Yeah. And we just started plugging that in our chats over and over and over and over and adding more people. And they're like, oh, we need a Discord. So I made a Discord. And then eventually it's like, oh, we need a website. Oh, we need this. Oh, we need that. Now it's like, yeah, really. I'm sorry. I'm bad about that. But the formation of the Knowledge Fellowship was a very slow development, because we weren't really sure in the beginning what we're doing. And Brain Bites, for example, was a team on Twitch, so we didn't want to step on their toes and be conflicting. So we're like, why don't we just make it a Discord with a list? And so people, just like a catalog, a free catalog, so people can look up whatever they wish to learn and find a streamer they like to learn from.
Nice.
And now we're over 100 creators. I'm going through the list very slowly. I wish it was a much faster process, but it does take time. It takes a long time. And Dr. W40 and I got so passionate. Like, we'd be sitting in calls for hours almost every day working on the Knowledge Fellowship, because we just wanted to find each other. We wanted to support each other. And the important thing for us had always been, and to this day is still, finding and sharing free education to break paywalls, to break academic paywalls. That's kind of what it finalized into becoming. Is we really want information to be free. I realized in the US alone, about 25% of the populace has gone to college or maybe has a degree, and that's not very much. That's only in the US. I mean, globally it's even worse probably in some countries, maybe better in some, but it's, I genuinely feel that by adding education to people's lives for no cost, no paywalls, no signing up or whatever. I mean, I guess you do have to sign up for Twitch, but you don't have to pay for anything. I mean, it's always great to support your edu content creators. I won't lie, gaming content is by far easier to do for me than an educational
Oh, of course, of
live.
course.
Right. So like make sure, and I never ask for money. I don't ask for money. I don't expect it, but I do support people supporting educational content on here if they can in any way they can. There's a lot of free ways to support too, because we're still kind of making our name on the platform, and people still to this day don't know that Twitch isn't just gaming.
Yeah.
So that's another thing I'm trying to like, hey, TikTok, hi, there's Twitch. Because I fully believe TikTok's probably going to get banned. So,
Oh, yes, yes. I keep forgetting that there might be no TikTok in the US.
Right. So it might just be for the US and whatever. But so that's the Knowledge Fellowship. That's how it was created. And Dr. WD-40 and I, by the way, there is another founder, Uncle Bill Druin. He was there day one with us. He was, I don't remember whose chat he even popped into first, but he was a viewer that was so frequently around and so frequently doing things we needed done for the Knowledge Fellowship that we're like, you deserve the founder role as well. Like, just because you're not a streamer doesn't mean anything. Like, you're doing so much networking. Like, you can just because that's just who he is. He loves learning, loves science, and loves sharing people with each other. And so the three of us kind of ventured out to create this thing. I know we have different like volunteering you can do based on your time. And Hoodles was one of the other streamers that first came on. Dr. General Andrews was another, or General Andrews, sorry, not Dr. General Andrews was another. He didn't end up doing educational content, though he wanted to. He was going to do fitness and wellness, but he was worried about lawsuits and things, because if you do give advice about fitness or medical things, that can be a slippery slope, I think. But I don't know. That's not my field. So I just deferred to his opinion.
Okay. So I should not be telling my lab rats not to lick or to lick batteries. Yeah, I shouldn't have said that last time.
Oh,
yeah, I shouldn't have done that.
I make jokes sometimes about the mineral cinnabar. I know it came up before I got on here, which is a mercury sulfide. And I was like, I always made sure to be like, don't lick it, guys. Because they were like, can we lick it? Because licking rocks is technically one of the things we can do to identify minerals.
You test if your battery is fully charged by licking it. It's a thing that was done. Sorry.
Yeah. No, I do. I actually do remember that. I remember my dad doing that.
Yeah, that's the way you tested it.
He's an auto mechanic. I didn't question it. But that's I mean, I think that's fine. It's a silly thing. Like, it's something that I don't know, maybe just, I'm sure it's fine. I don't know.
No one sued me yet.
No. I just, Twitch, honestly, like what I've realized, because I've been trying to live stream on TikTok for about a month or two. TikTok is like, we are going to put you in handcuffs and let you have a little sippy cup of water, and you can't talk about any mean things ever. If you say the word negative, ban. If you say the word apple, but it's slightly angry, ban. Like, it's, I don't know. It's
I said nipple. I said nipple once. I got banned. Yeah, I remember that.
On TikTok?
On TikTok, yeah. I said nipple.
Yeah, they do. I've been restricted for vaping when my vape was in my purse off of camera. I'm like, wait, how? So they're a little crazy.
Okay. Yeah.
But
just to bring
by
back,
the way,
oh, sorry.
I was gonna say, don't vape. It's gross. I'm trying to quit, and I don't like advertising it.
I
So
was just going to bring back about the knowledge fellowship that that
Mhm.
you did so much work, and obviously you give credit to where it's due, but obviously you yourself did a lot. And to anyone who is in my chat who isn't familiar with the knowledge fellowship, if you scroll on the about me page, there's even a tab, the knowledge fellowship there, and you can click it and join the Discord if you guys want to find new people to learn and learn a bit of science and stuff. And like Rocket Sage is in there and stuff.
that means a lot. That became such a huge passion, and it still is for me,
Mm.
the knowledge fellowship. And I will tell you guys, the hours, I call them D-dubs, Dr. W40, I call them D-dubs. The hours D-dubs and I put in, and Uncle Bill, I don't know how I did, because I actually did burn out last year. I don't know how I didn't burn out back then, because I was constantly just go, 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 go every day, all day in my office, working on the knowledge fellowship, and then streaming if I had time. So my stream actually did suffer, but we got to promote tens at the time, tens of content creators, which is, I think, a big deal.
Mm.
If I'm pushing 30 content creators doing education versus my own channel, that's huge. So, my own channel did suffer for it for a bit, but that's okay. Like, I was willing to take that um side effect, whatever. I
Mm.
brain. And it was the work was fun. Finding new people is fun. Trying to be, and you also, I learned a lot about myself, because managing something is very hard. Working and trying to manage a group of people can be intimidating, and especially as a woman, sometimes it can be even more tricky to navigate and understand and learn how to do things in a proper way. And I won't lie, I was not the best in the beginning. I was much more emotional. I didn't understand a lot of things, but I learned so much about myself, so much about communication, so much about different sciences, different educational sectors, whether or not we should include, or can we include, other languages, um, all these different goals we had.
Mm.
And I just appreciate the entire experience for what it's done for me in my life. And on top of that, it's also promoting hundreds of educators, where finally, by the way, if you haven't heard of us in the last year, it kind of did slow down. The steam behind the Knowledge Fellowship slowed down last year, as the three of us, I was taking care of my health. I took a break from basically all socials last 2023. I
Mm-hmm.
think Dr. WD40 was basically needing a break, and he finally took it when I came back. So I think we had just, it's been so many years, and we're like, oh, we're out a bit sometimes. That, and there are major changes in both our lives, et cetera, et cetera. So now I'm back to um, pushing things, getting things going. Uncle Bill's, of course, working with me, and D Dubs is going to take as long of a break as he needs, because they allowed me to do the same thing. And I think if you need it, you need it. And we're doing volunteer work anyway. So it's not like we get paid or we can pay anyone at this time. That being said, we are actually applying to become a nonprofit. Oh, there's
Ooh.
Kitty.
Yeah, I
Hey,
saw
Caddy.
cat. We saw a cat.
Yeah, come here.
Oh, this cat is so fluffy.
I love animals. This one's Caddy. Marshmallow is also fluffy, but she's a calico.
It's so
My
fluffy.
dog is like medium fluffy. Kitty.
Oh.
Okay, this cat is fooling you guys. This cat, like in the middle of the night, decides to go to war for her people and starts yodeling around the house and screaming. And it's like, why are you like this? This cat is tricking you guys with how sweet she is. Oh, so delicate and sweet. But then this gets covered in fur. This whole office is covered in fur. It's crazy. But yeah, I love her. I love the Knowledge Fellowship. It's always going to be a huge passion of mine, and I've learned, really, like, one of my favorite things personally is that I've learned to, you can't completely turn your bias off. That's impossible. But I've learned to really, like, hone it down
Mm.
such that I can critically look at a content creator and not put anything any of my personal feelings about that person, they can all be pushed aside, and I can directly just see, okay, are they doing educational content? Is it clearly, there? Are they doing it like once a week? And just easier to vote, nominate, and all that, which I know people don't normally talk about these things, but I don't know, it's important. And
No.
I just appreciate the growing
Being
experience I've
self-aware
had.
and growing up
Yeah.
with it. No, it's really important. I always try to self-reflect and see if I had bias in any kind of just even simple communication in everyday life. And
But any support for TKF, like you have it on your Twitch page. We don't even we don't have any requirements of anybody who we support in the Knowledge Fellowship, but I very much appreciate that you do that. We have assets if people want to use them, but it means a lot to me, Tofu, that you do that.
No,
so
no,
thank
no.
you very much.
I'm happy to be, a member of TFK. Is that
Yeah,
TKF?
when I found out you
Damn
were
it.
here doing streams, because I just come back from my break. Sorry if I interrupted. I'm bad.
No,
at
no, no.
that
You
a little
didn't. You
bit.
didn't. I finished a sentence. No worries.
I came back and I saw a couple new people. You were one of the new people I'd seen. I wasn't sure when you had started on Twitch. And I was like, oh my gosh, this girl's good. Like, she's passionate. She knows her shit. Like, she's she's a badass in science. Like, hell yeah. And I was like, we got to get this like in TKF. And I brought it up to D-Dubs, and that's when I actually started coming back. I was like, hey, is Tiny Toxic Tofu listed as a member in the Knowledge Fellowship? I've been gone a year. Like, what's going on? And they're like, no, who are they? And I'm like, you don't know who they are? And so I like spam them at you. And I'm like, can we just like go ahead and make this? Can we just do that? And then I realized that there were a few
backlogs.
I don't know, I want to say 20 content creators right now that need to be approved that we just need to get through.
Yeah.
So hold on to your horses if you're out there. We are working on it.
Working hard on it.
And yeah, we are. But I was so excited when I found your content because I knew, I don't know. I just felt, I don't know. I don't know if there's a physicist, solely physicist. There's astrophysics.
Yeah, there's a lot of astrophysics, but what I teach, I guess I would classify myself as a general physicist. I teach general physics, but I've yet to find. But if anyone ever finds a physicist, please let me know for TofuTechTalk, but also like collabs would be really cool in future. We definitely. Sorry.
I was gonna say, I remember when I started, I was the only geologist on Twitch that I knew of streaming geology.
And we have a geologist in chat even right now.
And now we've got a section of geologists. Volcano Doc. I think you were the second one. It was either you or Danny. I can't remember now. Paleontologizing came around as a paleontologist. However, he did request not to be moved from the section, but he said to me on a live recently that he's more on the biology side of fossils than the geology side.
Okay.
So I need to ask him where actually he wants to go. But now there's Volcano Doc, there's GeoGem, there's myself, and there's paleontologizing. But paleontologizing, like I said, did say that he is more on the biology side, but he does know a lot about geology. Don't let him fool you.
He's really, really cool. He's in digs at the moment. I think coming back soon, if I'm not mistaken. And not that I stalk paleo. No, totally.
No, it's hard to catch. It's hard to catch everyone, and I think you are probably.
I'm on the wrong time zone. I know.
Live, yeah.
It sucks.
I've been playing around with my schedule,
so many amazing content creators, but in the American time zone, and I just can't catch most of them live, which breaks my heart. It's very unfortunate.
But we also appreciate you being in another time zone because we need more educators in other time zones. Europe is ready, Australia is ready, all these continents are ready.
Let's go. But thank you so much for the fellowship and the content that you created. I am wary of the time a little bit because I only logged you in for 2 hours, which I apologize. Sure. It would have been great to have you longer, and I want to power through all the questions people gave you.
Oh, that's right. Do you mind if I just take like a 2 to 3 minute stand up?
Yeah, no worries. I'll put it in the AFK screen. We'll be back. Welcome back, everyone. We just took a quick little break, and now we are back for the final segment of Tofu Tech Talk with Sage. We're just going to power through all the questions that you guys gave. So, Sage, your brain is going to be a bit fried because you're going to go back on some questions, and some of them are...
Oh, that's fine.
Yeah. First question is fantastic. It was over an hour ago. How hard is it to make a lab-grown diamond for completely legitimate reasons? Do you know much about how they make lab-grown diamonds?
No, I
Oh,
actually don't.
okay.
So I know that it's carbon that is covalently bonded, and that's what I know.
Mm,
And I mean, I know about the mineral diamond, but to make it in a lab, I think they've fairly much perfected that process because you can basically get perfect lab made diamonds. So if you want diamonds, buy them, buy them lab made. They won't have inclusions or impurities or,
mm.
like that. That's just my little tidbit.
And a little bit more
And
ethical
the
as well, probably
Right,
is the other
that's
part.
why. I just didn't know, like, how much to say on that. So,
Yeah, yeah.
it is, I think, more ethical to buy lab-made diamonds. The other thing you can do, guess what's also just carbon? The mineral graphite. Guess what that's in? Your
Pencils?
pencils. So
Where's, oh,
pencils are forever. So just give them a pencil.
pencils are your best friend.
Anyway,
I
so
was looking for a
awkward.
pencil. I can't find a pencil on my desk. Okay, clearly I don't like my carbons. Damn.
Yeah, so you can always just buy a pencil, and that's just tell your significant other it's the same as diamond chemically, just
Perfect.
different bonds.
Zir asks, do we know or have theorized that there is differences in geoscience on non-Earth bodies due to
Mhm.
conditions that are different to what we find on Earth? Okay, that question I don't think I registered in my head. Did that make sense
Just,
to you?
I need the first part reread at least.
Do we
What part
know,
about planetary?
yeah, do we know or have we theorized that there are differences in the geosciences on non-Earth bodies? Oh, okay, so what is the condition
Non
of theory and science at the moment of the geoscience of other planetary bodies versus Earth?
So other planetary bodies, so if you're not asking about terrestrial bodies, so there's basically 2 big groups of planets. There's the gas giants, the Jovian giants, and then there's the terrestrial
Hmm.
planets, which are rocky in nature. So I'm not sure. Your question kind of suggested you weren't as interested in the terrestrial stuff, but I'm going to give you a little rundown of just a brief rundown of
Hmm.
everything anyway that I know. Planetary stuff, I don't know very much on the Jovian giants, the gas bodies, not very much knowledge on. I'm personally more interested in volcanics, earthquakes, seismic um, energy, tectonics, and what and how other terrestrial planets are operating relative to our own, like how they're operating relative to our own,
Mm.
because there are Mars quakes, for example, that are very different
Ooh.
than earthquakes. And they are created for different reasons. And I actually do need to do a little research on that before I say too much more, because Mars quakes, they thought were caused by the cooling and contracting of the planet. And I believe they were mistaken. And
Ooh.
I can't remember now what they if they've even finally decided what the seismic energy is derived from on that body. But recently there was a paper suggesting the volcanic activity on Mars has been much more recent than we previously theorized,
Mm.
and that the planet actually may not be as dead in terms of energy and heat as we thought. So it's there's a lot to unfurl there that I don't know, but that's a little bit that I do know about Mars. And Venus is also another planet they think
Mm.
is actually still volcanically active. We've only recently
Confirmed it.
suggested this.
Oh, okay.
I don't know that we've actually confirmed it. It's been
Mm.
recently suggested in a paper that volcanic activity on Mars is still occurring. So I don't know that I don't think it's a theory. I think it's just a hey, we have some evidence that suggests this.
Mm.
And geologic evidence can be highly interpretive in some cases and isn't it's not like A plus B equals C and you can find a definitive answer every single time. Sometimes it takes a team to interpret data and understand what's happening. Um, because Earth, for example, is by far from perfect. It doesn't fit into our perfect little examples of, for example, the 3 types of tectonic boundaries or what makes a mineral.
Hmm.
So there are outliers, and especially as we move to other planets, there are going to be even more outliers that we probably don't have everything we need to fully understand yet. That
Okay.
is, I think, the best answer I can give.
No, that's a very good answer. I really like that. Moving back.
Astrophysicists and planetary geologists would know a lot more.
I'm learning all the stuff from Mars. The question to bring it back to Earth: where in the world is your favorite geology? What is it, and why is it cool?
Oh, man, it's got to be something mountainous for sure. But that's more ecologically based. I love forests, just
Okay.
big pine trees and redwoods and the sequoias. And I grew up in Oregon where it was just mountains and forests and very rainy, very green, very rainy. I'm sure you're very familiar with those. Uh, because I used to have calendars of Ireland all over my walls when I was a little girl. I was like
Home
dead
sweet
set on
home.
living in Ireland and being in
Oh
Ireland,
God.
and I wanted to become Ireland. I wanted to move there so bad.
When you go hiking in
And
these areas and stuff like that, and you see the side of the cliff and the rocks, and like just when you go on nature walks or hikes or anything like that, do you actually like stop to look at rocks and
oh
commentate?
yeah,
And yeah, it takes over. Yeah.
uh-huh. It's hard not to because I've always been really like I loved nature since I was a child. My mom was doing a class at one point because she was in college for a little while I was a kid, a botany class where she had these two 5-inch binders filled with pressed plants and notes next to each of the plant. And I thought it was so cool. And I wanted to be a marine
Wow.
biologist at the time.
Oh,
And
we all
so
went
I
through
had
a
all these
marine biologist
facts,
phase.
right?
We
I
all
had
did.
these
Yeah.
these like children textbooks on marine biology and these
Mm.
paper whales. Instead of paper dolls, I had paper whales. And each whale was like there was the humpback whale, there's the blue whale, there's the orca, whatever.
Mm.
And I had facts about that whale on the back of each one. I had them all in my little I was obsessed.
No, that's
And
class.
so like I tumbled rocks, but I didn't know of geology really till I went to college.
Mm.
And that's when I started really learning. But the place, if I had to pick a place, it'd probably be the Redwoods because the Klamaths and the Cascades, well, that's more of the Klamath Mountains, but they're fairly recently formed. It's not so much that the Klamaths are interesting geologically, they are. Oh gosh, it's also interesting. It's mostly the ecology there too. Anyway, it's the
No worries. No,
Redwoods.
no. Okay, there we
I'm
go. We
trying
have
to
a
think
confirmed
of
answer. How does climate change affect volcano activity? There's a question.
it doesn't.
Oh.
Climate doesn't really affect volcanoes. The volcanoes operate based on the heat that's within the earth.
Mm-hmm.
So it doesn't really matter. The heat that's within the earth is from the primordial heat of formation and radioactive decay, primarily. That's where most of our heat is coming from. So once I guess radioactive decay is done and that's it, the volcanoes will stop. Climate, yeah, I mean, oh yeah, it does melt glaciers. It can melt glaciers. It can interact. So the biggest glacier in Europe is in Iceland,
Mm-hmm.
and there are several volcanoes beneath it. So they're capped by a glacier.
Wow.
When they erupt, there's a most of the volcanic activity that's recently been on the news, if you've noticed, has been a lot of fire fountaining and
Mm-hmm.
running lavas.
Yeah.
Whereas if a volcano pops in Iceland that's under a glacier, it's highly explosive. So I guess that's one way climate could affect the geology is if we go through a cooling event and more volcanoes are capped glacially, more volcanoes would become more explosive because
Okay.
magma, lava, and water interactions are highly explosive. Ask
Okay.
Volcano Doc for more.
Yes, plug in shout out there if you guys want way more details of volcanoes. Make sure to follow Volcano Doc in the chat.
I just saw it. I was like, hey, perfect.
Perfect. It's
But
perfect.
so volcanoes can affect climate, and I mean,
Basically, indirectly, they themselves don't, but they could affect
yes.
glaciers and
So
yeah.
no, volcanoes do affect climate, but
Oh, sorry.
climate doesn't really affect
Yeah.
volcanoes.
Wrong direction.
So you have a big enough eruption, basically, aerosols and ash will block out the
Yeah.
sunlight. You have a global cooling effect for 1 to 3 years,
Mm.
depending on the size, maybe longer.
Mm. The whole game of Frostpunk is based on a super volcano idea, which got delayed and I won't be playing this year or this
Oh,
summer, unfortunately. It'll take a few
I didn't
months.
know
They're
there was a
perfecting it.
geologically based game.
It's like it's a survival building game, like a city survival kind of thing. It's called Frostpunk. The second one is coming out. You should play the first one. You and Volcano Doc should and do the science on it. Oh my days! Oh my days!
I was trying to use city skylines because they had topo maps.
My
I'm
God,
like,
Frostpunk
there's
would
a
be so much
better
better
game?
from a geology perspective. Please. Oh, it's so good.
Okay, Frostpunk.
Sorry to get distracted on that.
Move up, you're here. I know you're here. Remember that. Frostpunk.
Frostpunk. Oh, it's so good. The last question coming in from Phantom. Why do carbon capture and storage projects fail to meet their targets? Is it poor implementation issue by industry, or is it something else?
I assume the targets, depending on who's giving the target.
Who's the narrative? What's the narrative here?
Who's the narrative? That's going to be a big thing there. So if it's a, I don't know, a company just making money, and that's all they care about is making money, they're going to make it look as efficient and as amazing as possible. So their target is probably going to be on the high end of estimations. So rather than, like, let's say there's a 0 to 100 range for some unitless figure.
Okay.
Let's say the high end is 100 and 100% that it'll work correctly, or zeros. I think they estimate towards the high end of things perfectly going as planned, versus accounting for and including, I mean, this goes including other variables that probably need to be included. This really does get into politics
Again,
and who's making money and the narrative.
Okay.
Is what I've kind of come down to realize, unfortunately. Some people that are doing science aren't necessarily doing bad science. They are paid to do a specific thing that makes a company look a certain way. If that makes sense.
Yeah.
There's kind of a movement right now, like, against academia and in some communities, and so it's hard to talk about this. Like, I try very, very carefully to talk about this, because they're like, the scientists that I've met have been amazing and truthful and honest, but there are outliers occasionally. And more than that, there are companies that are paying people to do something specific that they maybe know, like, hey, I'm going to tell this scientist to look up this set of data, but ignore these data points. Even if they want to look at those data points to be a more well-rounded answer, I'm going to pay them not to do that, so that it makes our company look a specific way. So here's our data, but they're just maybe not getting everything they should. And that's my opinion on what I think is happening.
Okay. Oh, wow. Yeah, but I understand not commenting too much in academia. I too know that I can't comment too much, unfortunately, on that area. And statistics are weird like that, for sure. I'll just jump in with a quick last question again. Sorry, from Jimmy. Can you pronounce that one volcano's name in Iceland?
Fagradalsfjall.
Damn it! You a volcano? God damn! well, I can't comment if that was well done or not, but that was a better attempt than I would have ever had.
I have, I know I'm still not pronouncing these 100% correctly, so I'm always curious what my accent's like, or what I sound like in Iceland to Icelanders. But yeah, Fagradalsfjall is the one that's currently erupting, I believe, and Grimsvot and Katla are two of the others that are buried under glacier that become highly explosive and make the news a lot too.
Yeah.
You wouldn't believe that.
But thank you so much, Rocket Sage, for coming on. Is there another one?
Oh, sorry. Eyjafjalla Jökull. Something Jökull. It's like a TL noise at the end that I don't know how to make. Eyjafjalla Jökull.
Damn, you guys are good. Very good. Well done. But I just wanted to say thank you so much, Rocket Sage, for taking time out of your day, out of your usual schedule, because obviously you're coming on my TofuTechTalk in my time zone. So I really appreciate you putting effort into coming on to TofuTechTalk. It's been such an honor and a blast having you as a guest. To all my community, if you guys don't follow Rocket Sage already, what are you doing? If you hover her name in the title, it'll pop everything up. The Twitch, the Twitters, the Instagrams. What else is out there?
Wait, the actual title of your stream does that?
Yeah, so if you put someone's @ in the title and you hover over it, everything pops up. It's what I think is a great way of promoting people.
My derpy brain was like, the picture, the image, let's click on it.
No, I think it's a good thing that Twitch added. I feel like it's so easy then to follow people on all their socials immediately, because it's nice for me to keep tabs on Twitter.
I feel like a little weirdo, like, I'm going to go follow all 4 of your socials right now when I find you.
No. But thank you so much, Rocket Sage, for coming. Really appreciate it.
Me. This is lovely.
Yeah. Do you have any last things to say before we end the podcast?
Oh, my community was wanting to know when your regular stream is, Isn't it? Is it on your page? I had
Yes,
a couple people ask me.
I usually stream from 12 p.m. my time, which is UTC +1. So I think I have a few American dedicated followers on my stream. They get up at 6 o'clock in the morning to watch me.
So I think if it's 8, you said 8 p.m. your time?
12 p.m. my time, I stream.
12, so noon. So that would, I think, be 4 a.m. West Coast.
It's okay,
Time?
guys. You
We're-
don't
I-
have to come on to my channel.
I think that we're very similar. Apparently, my OG and best friend moderator, Muga Fuga, has seen me play games and seen me do this for years. And he apparently said that we play games very similarly, which I thought was funny. I don't know.
Oh, right. Yeah, there was a few clips playing during the ad break. I also
right.
apologize for the ad break earlier. There was a clip
Oh.
there that was playing that shouldn't have happened. I'll take that off for the front page event. Anyways.
But I'm sorry if I remember. But yeah,
No.
So I think it's 4 a.m. roughly to 8 a.m. Our West Coast time is what it about sounds like.
But thank you again. Really appreciate you coming on to TofuTechTalk.
No, thanks for having me. And I look forward to having you on my channel.
Yeah, it'll be so cool. I haven't been invited to a channel yet, so it'll be really cool for me to go and talk on someone's channel.
I'm DMing you now. We're making this happen. You're gonna be my first collab as I come back.
Perfect. But I'm going to say my private goodbyes to Rocket Sage behind the scenes, but I'm going to raid over to a community now, a lady who's playing Elden Ring, but she is a woman in STEM. Her name is Skylibs. She was on TofuTechTalk. She did a master's in solar sails and space travel. So really cool lady. And she does talk about her research and stuff like that. And she just graduated with her master's degree. So let's give her a little bit of love and support during Elden Ring. Yeah, exactly. But
I love that game.
See you guys. Bye-bye.